say it again. I said it, I'll say it again. You don't understand what's going on here. I said it, I'll say it again. I said it, I'll say it again. I said it, I'll say it again. I said it before, I said it before, I said it before, I said it before, I said it, I said it. You don't understand?
Felt like a boonga butterfly. Felt like a boonga.
It's so easy.
Felt like a boonga. Felt like I felt like a
Somebody go get it.
like I felt like a
It's so easy. Somebody go get it.
felt like a butterfly. Felt like a butterfly. Felt like a butterfly. I felt like a butterfly.
I don't understand.
I felt like a butterfly. I said it.
You don't understand what's going on here. I don't understand, I'll say it again. I don't understand, I'll say it again. I don't understand what's going on. I don't understand, I'll say it again. Again. I don't understand what's going on.
Bingo, go.
I felt like a
I don't understand, I'll say it again. I don't understand, I'll say it again. I said it. I don't understand what's going on here.
fantastic, so degrading. You wonder if it isn't all a dream, a nightmare. And a man who lived after death, lived on human blood, took the form of a vampire bat, and lured innocent girls to a fate truly worse than death. Dracula.
I am Dracula. I am Dracula.
So efficient. Okay, we converted this stuff pretty slowly, but at least we got some points. Takedown. I'm really surprised that we managed to get rank 47 on here with so many bugs being written. Okay, this was really fast, all 4 minutes. Everyone looks like they clustered a... Oh wait, oh this was 2-part solve. So we ended up around here. Probably could have been somewhere here if we didn't kill the initial bugs. But this is an interesting question. I wonder, did that bring us to... We have 365 points? We're not anywhere close to top 100, but it's not bad. We actually got some points. Let's do a recap of this day though. So, I guess, are we still in like mirror land or something? We're in some space with empty spaces, mirrors, and these splitter objects. And we have a beam of light, and it starts in the top, or around here, I guess, in the top left corner, and it's heading to the right. So it's heading east, I would say. And there's some rules. If there's empty space, which is a dot, the beam of light will just keep going the way it's going. If it sees a mirror, so something diagonal facing, it'll like reflect off. So we would go here and bounce up, or go down and bounce left, etc. So that applies to these mirrors and these mirrors, the two diagonals, slash and backslash. Then the horizontal bar and the hyphen are splitters. If we encounter a splitter and we are aligned with it, we just go straight through. I guess the light kind of would just wrap around it and keep going. So simple enough, it's treated as if it was a period, essentially. But if we're coming at it across like this, we create two beams of light and we go up and down. If we ran, I guess, if we were coming up this way for some reason and hit this, we'd have two beams of light, one going left, one going right. Now every tile that a beam of light touches is considered energized, and the thing to solve with this puzzle is counting how many tiles become energized. So we essentially just have to simulate this. So I was wrong at first because I thought that we were entering going down. There's too many simulation puzzles where it's like dirt or like water falling down from the sky, so I just assumed we were going down. I didn't see that we're heading to the right. But we basically just write a simulation, this loop, where we start at the start and we're heading right. In my code that's called east, or capital E. And if we bump, and we basically just encode all the rules. So if we see a dot, the next place, I call them balls, just because, but it's light, right? If we see a dot, the state that we want to store is our position, where the ball is, and the direction we were heading in. So if we see a blank space, our next state to explore is just where the ball will be going. So my directions are encoded as basically like 0, 1 tuples. So 1, 0 would be moving the positive x to the east. So I can just sum them to go over to the next space. And we maintain the same direction. The next day we want to keep going the same way. If we see one of the slashes this way, we want to basically switch directions. And so we write this very silly code to avoid writing a bunch of if else, where we index into one list based on what our current direction is. So this is just saying if we were going north, which confusingly in my code is positive y, so actually going down in the direction. If we were moving down, we want to end up going west, so that's why north corresponds to west. Likewise, if we were going east this way, we want to end up going upwards, which corresponds to s, south. So that becomes our new state. We pick our new direction and then append the new state, and it's just opposite mapping for the other facing mirror. Then we handle the splitters. So if we were moving in the vertical directions and we see this this guy, it's treated as blank space, like the problem says. So this is the exact same code as this. Likewise, if we see a hyphen and we're going east-west, we also keep going the same way. But the interesting thing is, if we go, if we're going not in that direction, we want to create two new states, one where we went up and one where we went down. So that's why our search is basically a list. We just append two new states. Otherwise, this means, because we're using a sparse matrix representation of the grid, we don't do anything. That basically means that a ball has left. For the longest time, I thought that we were getting infinite states, but what was happening was we were bouncing back and forth between like in the real example and even in this example, things were bouncing back and forth and making it so that we explored so many states due to splitters, I guess, splitting over and over, or like mirrors cycling us. So there's one more thing that we had to do to make sure that the search actually terminates, and that's so seen is our count of like energized lists, because at the end we want to return how many we've seen. But we also want to store states that we've seen, so ball states, which includes your position and the direction you're going. And I think encoding the direction is important, because being here and moving down is different from being here and moving to because you might have a path that goes like down and loops around and goes to the left. You don't want to say just because you've been to this location that you can stop searching, because you'll miss energizing these if we were to continue going off to the left. So if you run that code, you get the answer, and then for part 2 it says the beam can enter from any edge and goes away from that edge. So rather than just starting at the top and going to the right, we can start like here and go right, we could start here and go left, we could start here and go down. I tried to cleverly do something to initialize this correctly after converting this into a function, but then it didn't really work out, so I just wrote it really explicitly. So we iterate through all possible directions of entering, of where we're going to start traversing the grid from, and then say we're going north, which is downwards. We try all x positions. Our y's are always going to be 0, and our x's range from 0 to n, where n is the length of the line. And then our direction at the start is heading downwards. And you just encode that for every direction, and then you pick the best out of all of those. This takes a while to simulate, like a few seconds in PyPy, but it's fine. Here's how big this grid was. So yeah, this is actually what's happening. So it's just like a lot of light bouncing around. And that's performant enough to solve this problem. So yeah, finally had an okay day after so many days, so that feels good. Wonder if the search problem, any more like search problems, or that VM looking question is going to come back, but hopefully we're ready for those. But yeah, we actually got some points today, which was good. Cool, thanks for watching.